Good morning, everybody. Happy Monday. Today, what I'd like to do is, I know some people have raised some questions and concerns about what we've been going over, and I know it's been a little bit tougher since I haven't been here, so I'm going to see if I can clear up some of the questions and concerns, and we can also address it on Wednesday when I'll be back. To get started, we're going to take a look at the standards just to get an idea of where we are so far. We've had to change things around a little bit because of me not being here, and some of the things I want us to do is sort of lab-based, and unfortunately we can't do that without me being here. So we've skipped around a little bit. We started off the year talking about properties of matter. Specifically, we've been talking a lot about density. And I think people have probably a pretty good understanding of how density works. So density just being how much stuff you have packed into a given space, and we can represent that mathematically with the equation density is mass over volume. So what I want you guys to be able to do is to work with this equation here: density is mass over volume. The next part, we're skipping over elements, compounds, and chemical changes, and we'll come back to that when I'm here. What we've done is we've jumped over to the periodic table a little bit. So all of matter is made of elements, and all of those elements are found on the periodic table, as you have hopefully seen from the activity that we worked on. What do I want you guys to be able to tell me from the periodic table is this. The properties, how elements are going to react, how they're going to behave, is very predictable, and we can identify this based on their location on the periodic table. Other parts that we want to be able to identify are: what is a group, what is a period, what is the atomic number, and how reactive is that element going to be. We also want to identify our metals, our nonmetals, and our metalloids. The periodic table is something we're going to definitely work with a lot over the course of the year, but those are the things I want you to be familiar with now. It'll make things easier later on, but I also want to point out that you will always have a periodic table available to you for on a given test or at any point. I will never take the periodic table away from you. You can always use it in this class for anything. So let's take a moment to look at the periodic table again and familiarize ourselves a bit. So again, real quick in summary. Properties, those properties can include things like what group are they in, what period are they in, what's their atomic number, their reactivity, their mass, and also are they metal, nonmetal, or metalloid. So this is the periodic table that we will be using over the course of the year, and what's wonderful is there's so much information on here that, again, you can reference on any test throughout the entire class anytime. So first of all, we talked about groups and periods. Well, what is a group? Well, there's a clue here. On the top of our periodic table, it has groups. These columns going down are the groups. The periods, if you can see, is labeled up here. That's these side parts here. For 2, it's period 2, period 3, period 4. So the periods just refer to the horizontal rows. Next, we want to see how some of the properties change as we move, maybe down a group or across a period. One of the things, it could be the mass. And if you notice, in each of those little squares, we have the atomic mass. Relatively, how heavy is one element to another? So here we have the example of carbon, which is has a mass of about 12. If you want to look at, well, how does mass change as you go across a period, if you notice, we can just look at the masses. We notice that in general, the masses increase as we go from left to right. There's one pattern. We also notice that the masses increase as we go down, generally speaking. So as we move down a group, the mass increases. Atomic number. The next part. We have our atomic number given in here also. It's always going to be a whole number, and it's basically the ID for the element. We will talk more about what this means, but for now we notice 1, 2, 3, 4, 5, 6, 7, and so on through the periodic table that the atomic number always increases by 1 from one element to the next. So, no surprises. As we go across a period, what does the atomic number do? It increases. As we go down a group, it increases as well. The last major trend that we want to look at is reactivity. For reasons that we'll get into later on, the two most reactive elements on the periodic table are in these two corners. They both begin with the letter F. We have, in the top right, we have fluorine, and in the bottom left, we have francium. So what that means is on the right side of the periodic table, as you move up, you become more reactive. This corner in here tend to be very reactive elements. On the left side, down here, tend to be very reactive elements. As we get away from it, lithium, a little bit less reactive. Something like scandium, also not the most reactive. Oxygen, chlorine, quite reactive. Something like silicon, much less so. Now, what happens in the middle? Well, it turns out they're all about the same. But the most reactive, what we want to remember, fluorine, francium, top right, lower left. Now, why don't we include this last column here? This group is called the noble gases, and as you should have noticed with those cards, these elements actually tend to not react at all. So this is sort of not the most interesting column. They don't react a whole lot. If you feel okay with that, that's the majority of what I want you to be familiar with in regards to the periodic table so far. The only other thing that I want you guys to be familiar with right now is the metals, the nonmetals, and the metalloids. So most of the elements in the periodic table are our metals. Where are those in the periodic table? Well, things like we see iron, cobalt, nickel, copper, silver, gold, mercury, zinc. These are all metals that most of us are probably familiar with in some way, shape, or form. So this whole side is going to be metals, as well as some elements that we wouldn't necessarily think of. Sodium, potassium, calcium, all of these are also metals. So our metals are going to basically occupy all of this of the periodic table and also down here. Not the prettiest, but we can see the vast majority of the periodic table, including up till about here. So these are all our metals in the red. Our nonmetals include our gases, nitrogen, oxygen, chlorine, fluorine, neon, argon, krypton, xenon. All of these are helium. So all of these are going to be our nonmetals, at least most of them. So this area in here, those are our nonmetals. Now, we can also we're going to throw a couple more elements in there. We're going to throw helium, and oddly enough, again, hydrogen is also one of our nonmetals. Kind of a weird one to place, so that's why we kind of keep it disconnected. Hydrogen is a nonmetal. Next, we have the metalloids, and that just means it's just a boundary between the two. Like, In some ways, they're kind of like nonmetals, but in some ways, they're kind of like metals. And that's going to be generally our elements in here. So throughout those scribbles, big idea, metals on the left, nonmetals on the right, metalloids in the middle, and we can always tell where our metalloids are because they're always touching this dark black staircase. So you don't have to memorize it, you just have to know how to interpret the periodic table. And a lot of that is going to be the trick over the course of the year, is knowing how to read this information. There's way more here than we've just talked about, but these are the first couple things I want you to be familiar with. We've got our groups, we've got our periods, we can read our mass, we can read our atomic number, we know our metals, nonmetals, and metalloids. That's all I want you guys to be familiar with. I know some of you may have had to memorize the periodic table and what all the elements are in middle school, and for those of you who had to do that, I'm sorry on behalf of all chemistry teachers. This is not something you need to memorize. I will give you a list of the majority of all these elements and what all those symbols, what they represent. And never in life will you ever have to have this memorized, but I do promise you by the end of the year you are going to have most of these elements and their symbols memorized. Why? Well, because we've worked with it a lot, but I will always give you the name of the element. So that's it. If you guys have questions, please email me and I'll try to get back to you as soon as I can. So don't sweat things. Work on it, take it serious, and I know you guys will get it.